The time frame that we have, and because of it's not complicated material, it's just a little bit different. So you have normal dominance, codominance, incomplete dominance, and you have X-linked dominance inheritance, or X-linked inheritance. You have something that's called multiple alleles. You kind of already experienced that with, don't worry about the sex link right now, put it away. If you got to finish stuff, finish it. I'll put the keys on tonight or today so you can take a look at it. We're going to do, you did a look, when the Calico Cats, there's called a multiple alleles. So not only are you looking at codominance with the red and the black, or the orange and black, but you're also dealing with an X-linked trait. It's kind of like with the blood typing thing. We're going to do this, it's called the ABO blood system. Does anybody know their blood type?
No.
No?
Oh.
I always forget. I think mine's O negative. My last hour tutor, he's in medical science right now, and they spent a lot of time working on that. You can have AB blood, A blood, B blood, and O blood. You can also have where they talk about the negative or minus on there, negative, positive. That refers to the rhesus factor. So we're not going to deal with that at all. We're just going to deal with the ABO blood system, okay? And there's a little bit more to it than I'm going to describe, but essentially I'm going to give you the basics. It's a situation where you have not only normal dominance and inheritance happening, but you also have some codominance happening. So watch, I'm going to draw 4 red blood cells. And I don't want you to get too confused with this, but it is what it is. We'll say this is the red blood cell, and this is, you can have A-type blood, you can have B-type blood. Now this is the phenotype. So we're going to talk about the phenotype first, then we'll talk about the genotype. You can have AB blood as a phenotype, and you can have O-type blood as a phenotype. Now the way that this gets this name is on the outside of every cell, just like with the red blood cells and any other cells, you have like markers and tags and things on the outside. If you're A blood, you have A-type markers, what they call antibodies, on the outside of the cell. If you're B-type, what do you have? B. Please work with me, guys. I need to hear you. On the outside of this one, you have both A and B, right? On the outside of this, you have nothing, okay? Now, the reason that they have these markers is it's designed to help the body out when you have certain things happen, like if you have a cut. They call it the coagulation. That means clotting. So if I get a cut, the red blood cells start to coagulate. There's a hormone signal sends off these clotting factors to that area that helps clot the blood up. The thing with the hemophiliacs is they're missing those clotting factors. We had a foster child for a little while that had something similar to hemophilia. He couldn't play football, couldn't play all different sports because if he got a little cut, it would just continuously bleed. If it was a bad enough cut, you could risk dying because you would bleed out too much. He would have to go to the hospital just like a hemophiliac would, and they'd have to inject through IVs these clotting factors that would help the blood coagulate. Coagulate just means to clot. He would get bruises that to us would be like real small. For him, just massive bruises because it would do all that bleeding internally. So you have these clotting factors that are kind of incorporated in your blood. So somebody who has A-type blood as a phenotype, they have these A antibodies on the outside. In their blood, though, the blood plasma itself, they have B-type antigens. Somebody who has B-type blood has A-type antigens, right? If you have AB blood, you don't have any antigens. You don't have any antigens. But if you have O blood, you have both A and B antigens. So this is basically how it works. If somebody were to take somebody who was A-type blood, and they've been doing transfusions for many years. Civil War, they have documented where soldiers would get wounded, and they'd literally transfuse blood from one person to another person. But see, with different blood types, it just kind of depends. And so sometimes what would happen is the person would get blood from somebody and they'd be fine. Sometimes they'd get it and they would die because they'd have this clotting thing. If I were to take B-type blood and put it in somebody who has A-type blood, these antigens would bind up with it and cause them to coagulate. If I took A-type blood and I put it in somebody who has B-type blood, the A-type antigens would coagulate without. If I put any type of blood in here with no antigens on the outside, you're going to be fine. What about here? What's the only blood I can put in with these guys? You can only put O-type blood with these guys. If I put A or B or AB blood in here, the antigens will start to bind with them and cause them to coagulate. Okay? Now, I don't want you to get caught up with that too much. That's not a big deal necessarily. Well, it's interesting to know, but I've actually had to explain it to teachers sometimes because they're like, I don't, what? Antibody? And I'm like, even science teachers, I'm like, just, it is what it is, okay? And it's pretty basic. There's more rules that go along with it than that, but this is the phenotype. Here's what I want you to realize, the genotype. If you have A blood, A and B are codominant to each other. O is recessive to both A and B. All right. So if I have A-type blood, I can have two possible genotypes. Remember, you get two letters for each allele, right? Or you get one allele for from each parent. So if I'm A blood, I can either be AA or AO, because O is recessive to both A and B, right? You can know your phenotype, but you don't necessarily know your genotype. If I have B-type blood, what is my possible genotypes? BB or BO. Now, what's the only type of genotype you can have for AB blood? You can only have AB. What's got to be your genotype for O blood? OO, because O is recessive to everything else. So the only way you can get O-type blood is to have the OO alleles. Okay. So this is one other interesting thing that went along with it, and we'll deal with this in this packet a little bit. That when back in the day before they have all the DNA technology they had, they could do blood testing on people to see if certain kids, if there was a baby mix-up or somebody was a long-lost relative or something, they could figure out, hey, was this person related to him? But you can see that when we go through this, there's going to be issues with it. What they can use blood testing for really is to see if you're not related to a person, okay? And you'll see how it kind of works. All right? Go ahead and look at that packet. We're going to try something here real quick. See if this works out for you guys. Look at the top. Read along with me, please. I don't normally do this, but we're going to try it. You ready? Start from the beginning. There's three alleles for the blood type gene, A, B, and O. So they call it the ABO blood system. The alleles for A blood and type B blood are codominant, while alleles for type O blood is recessive to both. Therefore, there's four basic types of blood that are determined by the presence or absence of these alleles. These three alleles combine into 6 possible genotypes. So we've kind of already done this before. Do this, so where you have AA blood or AO, what type of phenotype would that be? Put a little bracket there and put a little A blood there. If you're BB or BO, what type of blood do you have? Are we doing this together or not? B blood. Okay. AB is what type of blood? AB only. And OO is what? O blood. Right? Now watch, I'll show you how this works. So it's possible to prove the parents of a child by completing a Punnett square. Be sure to include all possible genotypic combinations for the 7 couples. So I've got 7 couples listed below. For this, in the first column, the male's blood type is listed first, then the female. For the second column, determine all possible genotypes for the parents, putting the male's genotype in the top box, females in the bottom. Complete the rest of the boxes in each row, then answer all the questions that follow. So I've already done the first one for you, so watch. If dad is type A blood, what possible genotypes could he have? AA or AO. If you're O-type blood, what's the only possible genotype you have? OO. Now watch, this is a weird thing, because if you really wanted to do it right, you get to set up all these Punnett squares and figure out who's who, but you got to just mentally do a Punnett square. If I do one allele from each parent, this is dad up here, and we said this is mom down here, and I take one allele from each parent, watch what happens. What if this allele goes with this allele? What's the genotype? What about this one with this one? What about this one with this one? This one with this one? Okay, do you see the pattern we got out here? So the 2 possible genotypes you can have are AO and OO. So what type of phenotypically, what possible blood types could the kids be? If those are their genotypes, their blood types are going to be what? A and O. So what could the kids not be? They can't be B and they can't be AB, right? You want to do another one? Austin, question?
Yeah, in blood type, that's not like there's certain people that can't have babies with blood
There are some situations, I don't want to get into that. There are some weird things where kids can be in utero with mom and it'll interfere with their blood. It's a weird thing, and it's pretty rare.
Because my mom has lost babies because of
That's a situation, and it happens every once in a while. There's all kinds of genetic things that happen. Like when you guys look at the color blindness crosses, where dad can be colorblind. Like look at this. For like girls that have, does anybody have a dad who's colorblind? Your dad's colorblind? You carry the colorblind allele. So right now, when you guys did all those crosses, this guy, who else? Somebody else colorblind? Ray, your dad's colorblind. Do you have a sister?